Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 12 students in advanced functions who are studying the logarithmic functions unit. This is the second video where I solve some log equations. So these are the equations we've been looking at. It's from a review package I handed out for the test. And in this video, we're going to be looking at G, H, I, and J. So let's just jump into it. So we're solving for x. And even though it doesn't look like a log equation, it looks like an exponential equation. Obviously, those two things are intimately related and can't be separated mathematically. X is in the exponent, and that's a problem because how do I solve for x in the exponent? Well, we learned that what we have to do is we have to take the log of both sides and then apply the property that allows me to take an exponent and rewrite it as a multiply. So you're allowed to, because this is a single statement or a single base and a single base statement, we can take the log of both sides as long as we take it with the same base. And of course, because I know this is going to be some weird decimal, I'm going to use the base that my calculator knows, and that's base 10. So I'm going to start by taking log base 10 of both sides. And again, when it's base 10, you don't have to write the number because it's known that that means base 10. So now that I've taken log base 10 of both sides, that allows me to now apply the property of logs that says that this exponent is on an exponent, and we multiply exponents together. So this is actually x times log 2 equals log 7. And again, since I'm solving for x, my goal is to isolate x. So log 2 is just a number. I don't know what the number is at the moment. But since I'm multiplying by log 2, if I want to isolate x, I will divide by log 2. And at this point, I can just take out my calculator and type in log 7, calculator, log 7 divided by log 2, and it will give me, let's see, 2.8, well, let's get a little more here, 0.74, and what that means is that 2 to the exponent 2.8074 is equal to 7, and if you want, it's very easy to check that on your calculator. 7.0002, pretty darn close. So that's the answer for x. Okay, here's h. Now, we need to solve for x, and x is up here in exponent land. So let's start by saying, since this is a log statement, we'll apply the property that allows us to take x, which is an exponent, and write it as multiply. And then we'll look and see what else to do. Now, remember, I don't see a base, and that means this is base 10. So what I have here is log base 10 of 10. Well, that's just 1. So x times 1 is x, so x equals negative 1. And of course, I could have done that from the very beginning if I rewrite this. At the very beginning, I had this statement. And if I had just sort of mentally put that 10 in there, then I would have seen this idea, log base b of b to the x, and one of the basic properties of logs we studied is that this is just equal to x. So I could have from the very beginning said, hey, all of this is just x, so x is negative 1. Good, next question. So here's question I, and remember, I know what this base is, it's base 10. And so what I have is I have the base and I have the exponent, which means I'm going to rewrite this as an exponential expression. 10 to the exponent 1 is equal to x minus 4. So I'm just now solving grade 9 equation, add 4 to both sides, x equals 14. Oh, what a nice question that was. Too easy. And then finally, J. So have a look at this. Giving you a second, because I'm really hoping that you see what's going on here. What I have here is a quadratic. And if you don't see it, you can do this substitution so you see it a little more clearly. If I replace any log x with a, what I have is a squared plus 3a minus 10. Ooh, dear. Something just went crazy. A squared plus 3a minus 10 equals 0. And I can solve for a by factoring pretty quickly. So let's do that. So a plus 5, a minus 2. So I get that a equals 5, or a equals 2. Sorry, that should be minus 5. I know you said it with me. So now that I've solved for a, I can go back and replace the log x. So I get that log x equals -5, or log x equals 2. So keep in mind that these are base 10s because you don't see anything else. And so what I have, in both cases, I have base and exponent. So if I rewrite this, it becomes 10 to the exponent -5 equals x, which is 1 over 10 to the 5, which is 1 over a lot. 1, 2, 3, 4, 5. 1, 2, 3, 4. Yeah, 1 over 100,000. And over here, again, I have the base and I have the exponent. So if I rewrite this, it says 10 to the exponent 2 equals x, so x equals 100. And don't forget, whenever you are working in the world of logs, make sure that you don't violate the properties about your restrictions. And both of these are greater than 0, so they're my answers. All right, I hope that was helpful. You know, don't assume that just because I did this video that these are the questions on the test. You should be studying lots of things like quizzes and textbooks and work we actually did in class. All right, hope that's helpful. See you later. Bye.